the table are reductions. Look at what it says, the title again. Standard reduction potential. Can you have an oxidation potential? Yeah. We could even have a table with oxidation potential, but the Zundals chose not to put one in. They only have a reduction potential table. So you only get half of the values? Is that what it is? Well, no, you actually get all of them. Because, what's the opposite of reduction? Right. So if you just take these reactions, which all have electrons on the left, because reduction is the gaining of electrons, turn the reaction around, that would be the oxidation of the product. This thing oxidizing would just be that turned around. So even though this is just reductions, you have all oxidations and reductions on this table. Some reductions are favorable and some are not favorable. I want to show you this part of the table. Here's our baseline right here. The reduction of hydrogen ions to H2. That has a reduction potential, I'm kind of off here, right there, of 0. 0.00. So that's our baseline. The things down below, these are not as good at reducing as hydrogen is. Above, those are better at reducing than hydrogen is. So the higher you go in reduction potential, that means the more that substance wants to gain electrons. So what substance is the best of all at gaining electrons? Varun?
I was going to ask something about like oxidation.
Okay.
So it's like...
I have to be fair.
What? Oh.
Go ahead and ask your question. Oh my gosh.
What?
See, now this is what I'm talking about, Sarabi. Is that? Whoa.
What?
Okay.
Okay. So for oxidation, for
Oh,
if
this
you have,
guy's
like, an
awake for
oxi-
once. That's
What?
For a second.
Is that like what? Oh.
Okay.
Okay. So for like an oxidation table, is it like the more negative it is, like the better it is at oxidizing, or is
No,
it
the more positive, the better it is at oxidizing.
Okay.
We'll talk about that. We'll see.
Okay.
Good job, Varun. If you want to ask a question, you can be sorry.
Yeah,
All right.
never ask a question.
So who do we decide is the best reducer?
Fluorine. I think.
Fluorine it is. Yeah. The very top of the reduction potential table, F2. Boy, that thing wants the electrons. So it is going to have the highest reduction potential on the table with 2.87 volts. What else might be good? Hydrogen peroxide. You know how in peroxide you have the O2 negative 2, that means the O is a negative 1 oxidation state. Going to negative 2, it's got a potential of 1.78. It's very good at reducing. Your question about oxidation. If you take these things over here, let's say that we want to oxidize iron. Does iron oxidize easily?
No.
Iron oxidizing.
Yeah.
Wait a
Give me an
minute.
example of iron
Rust.
oxidizing. Rusting. That's what iron oxidizing is. Iron rusting. Is that a favorable process?
Yeah.
Yeah, it happens spontaneously, and let's see why. We're just looking at it. There's one of the iron
Oh my
oxidation
God.
states, and there's another one. Let's just take
That's
this
your
one.
favorite.
Iron reducing, iron ions reducing to iron metal. That is not favorable. That has a negative reduction potential. So if we turn this thing around and we make iron oxidizing to Fe plus 2 electrons, so just turn that thing around. It would, you just change the sign of this to be positive.
Oh.
So something with a positive electron, I'm sorry, not electron, a positive oxidation
Positive
potential
electron.
will be favorable as well. But you have to turn them around.
Electrons are positive. I would positive electrons.
Yes.
Go ahead, keep at it.
That was her. She started.
All right, so I had just already talked about hydrogen is like the baseline because it has a reduction potential of 0. What would be the oxidation potential of hydrogen then? When you have hydrogen, not plus, hydrogen gas oxidizing to 2H plus 2 electrons. What's the oxidation potential of that?
Zero.
Right. You just take that number and change the sign on it. Since it's 0,
Negative zero.
it's still 0. Or negative 0 if you want to.
Why? That is so.
Okay? So that's what we do. When you need an oxidation, just take the reduction and turn it around. But you have to keep in mind that you're looking for the oxidation of the product of the reduction. So when you turn that thing around, the product becomes a reactant. Kind of confusing at first. It's one of those things where you've got to practice some of the exercise in the book, and then you can start to get the hang of it.
Are we gonna be able to start?
Yeah, I will. I'll show you. Like some of them are sketch the cell and tell which is the anode, which is this cathode thing.
Oh.
I want you to just try to do a couple of problems tonight.
Okay.
Not a lot, a couple. I want you to do a lot over the weekend.
Drawing drawing. Come on.
Yeah, so like I was showing you on the table, some things reduce better than hydrogen, some things not as well.
Right.
Things that are more positive reduce better. They're more reactive. And then, yeah, there's a table that I was just showing you is on page A25 that's right after KSP. If you need an oxidation, take the reduction reaction, flip it around, and change the sign on the potential.
Oh, that's your mark.
Oh, yeah.
What?
Mine's
I like that on your
natural.
quiz, too.
Wait, what?
Mine is natural.
Yeah, wait, what is that?
So,
Ooh, fancy.
How come you never said that about my writing?
Because that's fancier.
But mine's
no,
really
hers is
fancy.
actually natural.
Yeah, yeah, I know.
Mine's I tried.
I like it.
Huh?
I like writing this one.
I can't. Like, my handwriting's just a mixture of crazy.
I was hoping to get through 2 more slides, but one was going to have to do it. I can hear you. That doesn't mean dawdle, so I can't get to the next slide.
So how was your day, huh? Good? Yeah.
Yeah. How's the weather going to be outside? Are we good with this one?
Nope.
Nick? Still ready?
So do they only give the reduction values?
Yes, the table only gives reductions. Yep. You got to turn around and get the oxidation. Can you read off from your practice?
What were you doing until now?
Oh.
Stalling.
All right. So, if I could show you this redox reaction. If we had a cell that contained this reaction, in the anode was iron oxidizing to Fe+2. In the cathode is copper ions reducing to copper metal. Could we figure out what the voltage, what the cell potential is for this reaction?
Yeah.
We have the table. We would look up the oxidation potential of iron. It's easier to look up the reduction potential of copper because we just take it straight off the table. For the oxidation potential of iron, we have to find iron reducing and then turn it around. You know what I'm saying? And change the sign on it. So I showed you just a second ago, iron reducing that to that was negative 0.44. So when we turn it around, it becomes positive 0.44. That's the iron that I was mentioning. And then the copper, if you look copper up on the reduction potential table, copper reducing has a reduction potential of positive 0.34. So like we did with Hess's law, if you add these two half reactions together, you'll get that reaction. And when you add two half reactions together, all you have to do is add their cell potentials, or half reaction potentials, and you'd get the cell potential. Now this comment down here that's written in purple, this one is important. I would say put a box around this one. A redox reaction will be spontaneous if it has a positive cell potential. We're used to something being negative for a spontaneous reaction, namely delta G. But in the case of when we know the reduction potential and the oxidation potential, if the cell potential is positive, the reaction occurs spontaneously. And you'll get the current to flow. Well, I was hoping to get to the next slide, which had the fact that the table gives standard reduction potentials, but we'll have to talk about what
Oh.
standard means tomorrow. If I could show you kinds of problems that
You can
I
stop
expect you'll be
recording
able to
now.
Wait.
do. And don't be a stranger to the solution guide at first.
What's the solution?
Yeah, but definitely.
Textbooks can be expensive.
No, they're not.
Unless you're like those cheap.
No, it's not my fault.
Take a look at number 41 and 42. Here's 42. 41 is just like it. Sketch the galvanic cell based on the following half reactions. So you're going to have two half reactions there. You need the, and by the way, when you're out of here.